All motors have some basic components in common. These common components include the frame, also referred to as the stator frame, the core and stator windings, the rotor and shaft, the conduit box, and the end shields, also called the end bells. The stator winding is connected to the power supply via the conduit box. Torque is generated by a magnetic circuit conducted by the stator frame. The rotor responds to and controls the torque, channeling the torque to the shaft. The shaft, in turn, channels energy to the driven equipment. The equipment delivers the required performance. With other apparatus products, you will need to discuss with your customers the requirements for their application. This will help you determine the correct type of motor they need. You should ask some qualifying questions. Here is a customer looking for a motor. Hello, I'm looking for a 575-volt three-phase motor that provides 10 horsepower. Your customer knows some important requirements for the motor he needs, but you will need more information to help him find the right one. The voltage and phase of the motor and its connecting circuit must be compatible, but you also need to know the number of cycles per second of the phases. In North America, AC is generated and flows at a frequency of 60 cycles per second, or 60 hertz. Your customer knows the power that is required from the motor. Horsepower, the equivalent of amperage for other apparatus products, determines the motor's load. Outside of the United States, horsepower is measured in watts or kilowatts. However, the frame size of the motor must also be known. Fortunately, the horsepower rating provides a valuable clue. The frame size of the motor is related to the motor's horsepower. Generally, the greater the horsepower, the larger the frame size. NEMA has set standards for certain physical dimensions for frames. The speed of the motor must also be known. The speed of the motor will depend on the operating requirements of the equipment to be driven by the motor. You may need to ask your customer what the motor will be used for to help determine the speed requirements. Motors of the same horsepower may vary in the number of revolutions per minute, RPM, or speed. Some motors are also capable of more than one speed. You will also need information about the desired enclosure, which is the motor's protective case. All motor enclosures are classified according to the way they protect the motor mechanically from the environment. These classifications are open, in which outside air is circulated inside the motor to cool it, and enclosed, in which no outside air is circulated inside the motor. An enclosed motor, however, is not airtight. There are several enclosure types within each of these general classifications. The three most frequently requested are open drip-proof enclosures, totally enclosed fan-cooled, and explosion-proof enclosures. An open drip-proof enclosure allows air into the motor for ventilation purposes, but protects against water and other particles reaching the interior. A totally enclosed fan-cooled enclosure cools the motor by means of a connected fan that draws air over the enclosed motor, removing excess heat. In some environments, a spark from electrical components or the heat created as the motor runs can result in an explosion. For example, if there are gases, vapors, or even certain types of dust in the air, there's a danger of explosion. Under these circumstances, an explosion-proof enclosure is necessary. It is important to consult with manufacturers and experts to make sure the right product is chosen for explosion-proof applications.